Hi, Professor LaShan back again. I'm going to start with number 7 on the Test 3 review for Math 107. So now we're going to go to some of the problems from section 5.2, the applied problems to the normal distribution. It says full-time PhD students receive an average of $12,837 per year. So that's our mean, mu, 12,837. Average salaries are normally distributed, so that means we can apply our normal distribution formulas, charts, tables, drawing, with a standard deviation, so that's sigma, the population standard deviation, of $1,500. Find the probability that A, the student makes more than $15,000. Okay, so more than tells us where to shade. So we're going to start by drawing the picture because you always need to draw the picture so you know how to do the problem. So in the middle is the population mean mu of 12,837. And 15,000 is more than 12,837, so we are to the right of the mean, 15,000. That's our data value x. More than means we shade to the right. These are people that are paid the highest. So what we have to do is we have to convert our data value x into a z-score using the z formula. So x 15,000 minus mu 12,837 over sigma 1,500. And that's from the formulas page, which you should have when you're taking test 3 and the final exam. So 15,000 minus 12,837, that gives you 2,163, subtract first, over 1,500. Divided by 1,500. This gives you 1.442. So this is a z-score, 1.442 round to the hundreds place, to 2 decimal places. Since it's our 2 here in the thousands, we're going to keep the 4. So we're going to go to our z-table. We're going to look up positive 1.44, which is our z-score. So we're going to go to row 1.4, and then we're going to look up at 400s, and this is going to give me this area here of 0.9251. Now that is the area where? To the left, because that's how our table works. It always gives us the area to the left. So we have to use the idea that the entire area under the curve is 1, or 100%. To get the area to the right, we're going to subtract 1 minus the unshaded 0.9251, which is going to give us our area 0.0749. So that's the probability that a randomly selected PhD student would make more than $15,000, about 7.5% probability. So question 7b says, this is the probability that a student would make between $13,000 and $14,000. Okay, so again, let's draw the picture here. So in the middle is our population mean of 12,837, that's mu. 13,000, a data value x, is more than 12,837, so it's to the right of the mean. And 14,000 is also more, so that's to the right of the mean. Sorry, x. And so what we want to do, and we want to shade between. An x. So we want to shade between because the problem said between. So we have to take those two values for x, 13,000 and 14,000, and use our z-score formula, the shorter z-score formula, and convert them into z-scores, which should be positive because we're to the right of the mean. So we're going to take x 13,000. Let me give myself more space here. We're going to take x 13,000 minus mu 12,837 over sigma 1,500. Let me do that one first. So that is going to give me 13,000 minus 12,837 gives us 163 over 1,500. Which gives me 0.108 something. So we're going to call that 0.11. That's our z-score. So let's look that up, 0.11 on the positive z side. So 0.1 and then 0.11 and 100th. It's going to give you this area, 0.5438. That is the area where? To the left. So this whole part, 5438. Okay, so now we're going to convert 14,000 into a z-score, which should also be positive because we're to the right of the mean. So we take x 14,000 minus mu 12,837 over sigma 1,500. So this is going to give me 1,163 over 1,500. And so subtracting, let me just double check my figures. And then dividing that by 1,500, we're going to get 0.775. So we got to round to 2 decimal places. I'm going to call that 0.78, 0.775. We're going to round that up. And so if we look up a z-score of 0.78 on the positive z side, row 0.7 and then 800ths, I get this area of 0.7823. That again is the area to the left. All the way to the left tail is 0.7823. So to get my answer, the shaded area, I'm going to take 0.7823, all of this area to the left, subtract the unshaded left tail, 0.5438. Move this over so you all can see it. And then I'm going to subtract 0.7823 minus 0.5438, and that's going to give me my answer of 0.2385. So that's the probability that a randomly selected PhD student would make between $13,000 and $14,000. Okay, let's go to 7C. In 7C, we want the probability the student makes less than $11,000. So less than is telling us where to shade when we draw the picture. So let's do that. Let's draw the picture. So if you recall from the earlier information, the mean of the population in the middle, 12,837. An x value of 11,000 is smaller than that, so you are to the left of the mean, somewhere over here. Less than tells us to shade to the left, so this should make us happy, because when we have something shaded to the left, this is always the easiest question. So we're going to convert that to a z-score. We expect that to be negative because we're to the left of the mean. So we take x 11,000 minus the mean 12,837 over sigma, if you recall, was 1,500. So this is going to give you negative 1,837 over 1,500. Which is going to give me a z-score of negative 1.224. So after the 2 is a 4, so we're going to keep the 2. And it's a negative, sorry. Negative 1. Let me write that neater. Negative 1.224. Our z-score is negative 1.22. So we are going to go to our z-table for the negative z side, and we are going to look up negative 1.22. So row negative 1.2, and then go down to 200ths, and we're going to get the area to the left of 0.1112. And that is again the area to the left, 0.1112. And that's our answer because we wanted the area to the left for less than. So 0.1112 is our answer, 0.1112. So about 11% probability or so. All right, and then 7D wants the probability that a student will make between 12,000 and 13,500. So the between tells us where to shade when we draw the picture. We need more space on this one, so I'll put it here. So in the middle is our mean of 12,837. Our x value of 12,000 is smaller, so you are to the left of the mean. 13,500 is larger, so you are to the right of the mean. And between tells us to shade between. So we have to convert both of those into z-scores. One's negative, one's positive. Look them up and then subtract to find our answer here. So starting with x is 12,000. Should be a negative z-score. So x 12,000 minus mu 12,837 over sigma 1,500. So this is going to give me negative 837 over 1,500. When I divide that in my friend the calculator, I get negative 0.558. So since there's an 8 after the 5, I'm going to round up and call that negative 0.56. Let me do the other one and then we'll look them both up. So x is 13,500, converted to a z-score that we expect to be positive. So x 13,500 minus mu 12,837 over sigma 1,500. So subtracting that, 13,500 minus 12,837 gives me 663 over 1,500. Dividing that out, I get 0.442. So I'm going to keep the 4 because after the 4 is a 2. So I'm going to look those both up in my z-table. So I have negative 0.56. I'm going to start there. So negative 0.5 and 600ths. Pull that down so you can see that. So negative 0.56 is going to give me an area of 0.2877. That is the area to the left. And the left tail is 0.2877. And then I'm going to look up a z-score of 0.44 on the positive z side of the table. So row 0.4 and then 400ths. And that's going to give you 0.6700 right here. And again, that is the area to the left. Let me squeeze that in my picture here. So all of this area to the left, all the way to the left tail is 0.6700. Of that, I want to take away the unshaded left tail of 0.2877 to get our answer. Let me go to my calculator. 0.6700 minus 0.2877 gives me an answer of 0.3823. So that is the probability that a randomly selected student chosen would be making between $12,000 and $13,500 of those PhD students from a normally distributed population. So let me stop here and I'll pick up the next video with number 8.